Hey there, welcome back to the exam preparation video series for AZ-500, Azure Security Engineer Associate. I'm Peter de Tender. I'm a Microsoft technical trainer here at Microsoft. This is the third episode out of the total 4 episodes in this series. In this specific episode, we'll focus on secure compute, storage, and databases, where we will cover how to plan and implement advanced security for compute, plan and implement security for storage, and plan and implement security for Azure SQL Database and Azure SQL Managed Instance. Here is a list of the different skills for the objectives we'll be covering. As mentioned already in previous episodes, these are some of the skills you may or may not be tested on. We will not necessarily cover every skill in this video, but you should be familiar with each skill before taking the exam. A gentle reminder to pause the video or take a screenshot. And the same recommendation is obviously for this one. If you have been with us for the 2 other previous episodes, you already know we start each episode with a reference to the MCSB or Microsoft Cloud Security Benchmark controls. For this episode, the relevant controls are data protection, network security, identity management, and privileged access. So yes, there is quite some overlap with topics covered in other episodes already. But that's just how security works, right? The first technical topic we zoom in on here is how to provide secure remote access to your Azure running virtual machines. In short, you should know Azure Bastion, a serverless scenario allowing secure connectivity through a Bastion host, without your virtual machines needing direct public internet access. A second feature coming to mind is just-in-time access, allowing system administrators to connect remotely into Windows and Linux virtual machines using traditional RDP or SSH, but only when needed. So make sure, apart from the technical setup, you also know the license requirements needed to get this up and running. Another popular compute workload in cloud is Kubernetes, which in Azure means using AKS. For the network security specifically, you need to understand how to plan and implement cluster isolation, and when to use which option, the logical one or the physical one, based on the details in the exam question. Next, understand the use case for Defender for containers, allowing you to protect your AKS environments from 3 different angles: environment hardening, vulnerability assessment of the container image, and runtime protection of the AKS nodes and clusters itself. Last, make yourself comfortable with the way AKS provides or requires authentication. Managed identities, RBAC, conditional access, privileged identity management all got covered in episode 1 before, and they are all crucial in protecting your AKS scenarios. And also keep an eye out for the limitations mentioned on this slide as well. Now, AKS is only one of the several options to host and run container workloads in Azure. If you're using ACI or Azure Container Instance, you're mainly spinning up a single container-based workload, which runs as a service. So you don't have the same level of control and granularity as managing Kubernetes provides. But this doesn't mean you cannot manage, monitor, and audit what is happening in the backend of that container instance. Now we covered AKS, ACI, which means ACA or Azure Container Apps couldn't be left out from the list. Container Apps is basically running on top of AKS, but the infrastructure layer has been made transparent to you as the admin. Same as with ACI, it's not because you cannot manage that infrastructure layer yourself anymore, you should neglect monitoring. So for the exam, you need to know how to monitor and scan images for security vulnerabilities, but also how to watch over live running containers for any security issues and overall resource activity monitoring. as an unexpected load in runtime could actually also be an indicator of a potential security attack. Closing off the Azure Container section with ACR, Azure Container Registry. Azure Container images are stored in the repositories, ready to be picked up by your actual container runtime service like ACI, AKS, or container apps. It means you have to know how those services can securely connect to that container registry, from a networking perspective as well as authentication perspective. With that, we're jumping to another topic in this episode, securing storage. In this slide, it's all about disk encryption. Make sure you understand the different encryption options, when to use what, and how the service on the host are different between Windows and Linux. A little bit off topic here, but nevertheless crucial from a security perspective, is securing configurations using Azure API management. While not exclusive to storage or data scenarios, nowadays modern cloud apps are heavily relying on API calls across different services. This impacts domains such as connectivity, authentication, permissions, and more. This slide has 7 different domains, so make yourself familiar with each of them in relation to API management service. Back to a few slides on storage accounts specifically. This table is a great overview of what to know for the exam when discussing Azure storage. For each storage type, like blobs, files, tables, and queues, you have to know the different supported features from a security perspective, mainly zooming in on authentication and access levels here. A common scenario to establish connectivity and authentication to a storage account is using storage account keys to generate a SAS token. The best recommendation is storing those keys in a secure vault using Azure Key Vault. Go through the process in a lab if you can to become super familiar with the different steps to make this happen. Well, now this slide focuses on access configuration to storage account files and file shares. Common in a file server migration scenario from on-prem to cloud, end users need the correct authentication method to reach their files. Depending on the identity topology of the scenario, this might impact how this actually works. The same goes for traditional Azure Blob storage. Starting with needing the correct permissions provided through access keys or preferably role-based access permissions. Also remember that when you have storage account access permissions, you don't necessarily get access to the data within that storage account, or at least know how to avoid having that kind of access. Another aspect in relation to security is protecting the data in case of a cyber attack or even human mistakes. To avoid data loss, make sure you set up the necessary disaster recovery capabilities for your storage accounts, which means be familiar with soft delete, how to enable backup, how to perform data restores, and how to interact with immutable storage. We already talked about access keys and how to store them in Key Vault as a best practice. Azure allows the creation of keys, but you can also decide to bring your own keys. The process for key transfer involves the listed 4 steps. Obviously, you need to know how to perform these and also in what specific order. In this slide, we emphasize the aspect of double encryption, which means you have to set a parameter enable infrastructure encryption on the storage account level. And keep in mind, you cannot change this parameter anymore once the storage account has been created. This brings us to the last section in this episode, highlighting several security capabilities for Azure SQL databases. Starting with the first recommendation here, using Entra ID authentication to provide access to your database, instead of using the traditional SQL admin account. Knowing how Entra ID provides high-end security features they are now also becoming available to protect your SQL database services. Monitoring security means watching over auditing logs. Valid for most Azure resources, so not really different for auditing your SQL databases. Remember, you can enable database-level auditing, as well as server-level auditing. The information is different between both of them. Another interesting security best practice for a database is enabling dynamic data masking. What this does is masking the typically sensitive nature of data content inside your database, for example, credit card information, email addresses, and the like. While data masking is hiding information, the data inside the database itself is not encrypted using that. That's what TDE or transparent data encryption is providing. TDE encrypts the full database for data in transit, but also at rest, like in a backup scenario, for example. Encryption means keys, so no surprise there is an integration with Key Vault in this topology. Last, this slide covers several recommendations when to use Always Encrypted feature of Azure SQL databases. It not only covers pure security reasons, but for example also compliance regulatory requirements, threat protection, and others. Recognizing the use cases, but even more so, knowing how to implement them, is crucial for the exam. This brings us to the end of this episode, so let me close with another quick recap. In this episode, we covered Exam Objective 3, highlighting secure compute, storage, and databases. More in detail, we covered planning and implementing advanced security for compute, planning implementing security for storage, and planning implementing security for Azure SQL Database and Azure SQL Managed Instance. This group again represented 20 to 25% of the exam questions, so again an important portion is covered. Let's move on to episode 4, which focuses on securing Azure using Defender for Cloud and Microsoft Sentinel. I'll see you back in a bit.